Okay, so let's continue on our discussion of quotient rule. So this is the second part. Let's start with the review. So these are some of the tricks and shortcuts that you will be seeing when we continue working on the quotient rule. Number one, so I hope by this time you memorize the derivative of square root of x. So every time you get to see this derivative of square root of x, by memorization, it's going to be 1 over 2 square root of x. Okay. Now, the derivative of constant, so number 2, 5 is a constant. So in general, if it's a constant, its derivative is going to be 0, okay? And number 3, what we have right now is a reciprocal. You know, when you have a variable x in the denominator, that makes this a reciprocal. Now, this is a quotient rule problem right here because there's a fraction 3 over x to the fourth. So obviously this is a quotient, but if the numerator is constant and your variable x is at the bottom, your denominator, then it's a reciprocal and you can actually bypass the quotient rule, okay? And the shortcut or trick for this is we multiply this 3 and 4. So that's going to give us 12 over that variable x raised to the 4 plus 1. So we always add 1 to the bottom, okay? Exponent. So 12, that's 3 times 4, and then over x to the 4 plus 1. And don't forget to switch the sign. So from the original positive, its derivative is going to be a negative. Okay. So again, you can bypass the quotient rule if it's a reciprocal. Okay. So you can use the reciprocal rule. Or you can also bring up this x to the fourth so that variable x, when you bring this x to the 4 on top, it makes a 3x to the negative 4, okay? And the derivative of this is now going to be using the power rule. So this is no longer a quotient rule problem, okay? So you just have to use the power rule, which is negative 4 times 3 is negative 12, and then x to the negative 4 minus 1. So negative 4 minus 1. It's negative 12, x to the negative 5. So you can leave your answer the way it is, or you can also bring it down if you want. So that's negative 12 over x to the fifth. Okay? So that is actually the same as this using the reciprocal rule. All right. So continuing on the review of some of the derivative rules, so before we dive into the quotient rule uh, questions. Okay, so let's quickly review some derivative rules that we covered so far. Okay, so let's start with the derivative of constant again. So if you get the derivative of any constant, constant like 1, 2, 3, 4, 5, it's always going to give you 0. Example, derivative of 5 you saw earlier, or let's say 7, or it's a negative 7, it's going to be constant, so that's 0. Okay. Now, what about getting the derivative of say 4x cubed? All right. So 4x cubed is a single term. It's a monomial. Okay. Take note. This is the base x. Okay, for the exponent 3. So when the base is x, it's plain x. It's a numerator. Then it's a power rule question. Okay. So it's going to use the power rule of derivative, and the power rule says you multiply this 3 to 4, so that gives you 12, and then copy that same base x, okay? So that's x, and now raise to 3 minus 1, which is now 2. So again, that's 3 times 4 is 12, base x raised to 2, okay? So using the power rule. Now, number 3, let's say you have to get the derivative of let's say you have a 4, but the base is more than plain x. Let's say it's 3x to the fifth. And then this 3x to the fifth is raised to, let's say, to the 7th power. Okay. Now the base over here is no longer plain x. Okay. So when the base is no longer plain x, then we have to use the chain rule. Okay. Now from the word chain, it's going to be more than power rule. Now the first step is actually a power rule, but you have to do one more extra step. So what I mean by this is, the first step is going to be just like a power rule, where you multiply, say, the exponent 7 to the coefficient 4. So that's 7 times 4 is 28. And then copy that same base. Okay, so copy that same base, 3x to the fifth. And then raise now to what? So that was 7 minus 1 is 6. Okay, because the base is not a plain x, so we have to do one extra step, which is multiplying what we got right now by the derivative of the 3x to the fifth, which is 15. So that's 5 times 3 is 15, x to the fourth. So this is one extra step that makes it a chain. Okay, so this is using the chain rule. And all that's left right now is to simplify this, meaning multiply this 28 and 15. 28 times 15 is equal to 420. Okay, and then you can leave your 3x to the fifth as is. Okay, and that's our derivative using the chain rule. Okay, I think I forgot the x to the fourth, right? So I multiply 28 times 15, which is 420. Okay, and you can multiply this by that x to the fourth. Okay, so that's using the chain rule. You can leave your answer as it is, or you can simplify it further. Now let's look at the set of formulas that completes the differentiation rule. Okay, now the next derivative rule, or is the product rule. Okay, so that's the next derivative rule. It says that if we have, let's say, a product, let's say you have 2x plus 1 times 3x plus 2. So this is obviously a product of two binomials. Then the product rule suggests that we take the derivative of u. Okay, so let's assign this first binomial to be our u, and the second binomial is the v. Okay, so the product rule formula says get the derivative of u multiplied by v plus u times v prime. Okay, so our u here is 2x plus 1. I'm gonna go ahead and get the derivative of u. That's u prime, which is 2. Our b is 3x plus 2. So its v prime is 3. Okay, so following this product rule, says u prime, which is, okay, 2 multiplied by v, which is 3x plus 2, plus u, which is 2x plus 1, multiplied by v prime, which is 3. Okay, so this is product rule. Now you can distribute these two. You got 6x plus 4, and then distribute the 3. You have 6x plus 3. Okay, so your y prime will be 6x and 6x is 12x plus 7. Now at times, okay, at times you can rename the function, okay, if it's not really complicated to do some kind of algebra in the beginning, like here, if you want to rename it by boiling this out completely, meaning multiply these two, 2x plus 1 and 3x plus 2, which is 6x squared, 2x and 2 is 4x, and then 1 and 3x is 3x, 1 and 2 is 2. So sometimes, when you do the renaming in the beginning, it's actually simpler, okay? So 6x squared plus 7x, and then plus 2. So after you rename it, then you can go ahead and get the derivative. This time you don't need to use the product rule because we have these three individual terms that just require the use of power rule. Okay, so that's 12x plus 7, and this 2 is constant, so its derivative is 0. Right, so either way is fine. Okay, so use the product rule, or you can use the algebra to rename it, and then use the power rule, okay, to get the derivative. All right, the last rule is the one that's the main focus for this tutorial, which is the quotient rule, okay? So from the word quotient, quotient means fraction. So examples of those functions are like 2 over x, let's say to the fifth. So you have a fraction here, so you can use quotient rule. Another example, let's say you have x cubed over 4. So this is another fraction or quotient. So you can use the quotient rule. Let's say you have 3x plus 2 over 5x minus 1. So this is another quotient. You can use quotient rule. Let's say you have 3x to the fifth plus 4x over 2x squared plus 3x. Okay? So these are all quotient or fractions in which we can use quotient rule, or you have to use quotient rule. Okay? Now for 3 and 4, you really have to use the quotient rule, and the formula for the quotient rule is, let's say if you have a quotient of u and v, all right, so the derivative is u prime v minus u v prime, just like the product rule, except we have a minus this time, over v squared. Okay, so this is the formula for the quotient or the quotient rule. Now, again, number 3 and 4, you really have to use the quotient rule. Okay, and what I mean by this, if you look at the numerator, we have variable x on the numerator and at the same time at the denominator, right? So variable x on top and at the bottom. If you look at number 4, you have variable x also on the top and at the bottom. So you really have to use the quotient rule. Now, number 1, although you may use the quotient rule, but we have some shortcut in order to get the derivative, okay, for number 1 and 2. So the shortcut or trick applies when the numerator is a constant or when the denominator is a constant. So if the numerator or denominator is a constant, although it's a quotient rule question, you can actually bypass that quotient rule and use something that's easier to get the derivative, okay, of these two questions. So let's go ahead and show you that. So again, for that particular, let's say, fraction 2 over x to the fifth, so one shortcut or trick to bypass the quotient rule is, okay, so let's say name it method 1. You can bring this x to the fifth on top, okay, that makes it 2x to the negative 5. So this is no longer a quotient rule question, but a power rule, okay? So its derivative is negative 5 times 2, which is negative 10. x to the negative 5 minus 1 or negative 6. So now you can bring this down. That's negative 10 over x to the positive 6. Okay, or you may also use, okay, the reciprocal rule, because again, if the numerator is constant and your variable x appears at the bottom, then you have a reciprocal. So this reciprocal rule or trick is actually a shortcut or a way to bypass that quotient rule. So what you do is multiply this 2 and 5, so that's a 10, over x to the fifth plus 1. So now it's a 6. And also the last thing you have to do is switch the sign. So we have this negative 10 over x to the 6. Right? Now, if I turn it upside down, so if I say now I have x to the fifth over 2, okay? So this is a fraction, but take note, I can rewrite this as 1 half times x to the fifth, okay? Now, this is not different from, let's say you have 2x to the fifth, okay? So the numerical coefficient is 2, and your base is x raised to the 5. So the derivative is just going to use the power rule, okay? So you multiply 5 and 2, that's 10 x to the 4th. Okay, so again, x to the fifth over 2 is simply 1 half times x to the fifth. So now it's a power rule question. So you multiply 5 and 1 half, which is 5 halves, and then x raised to 5 minus 1, or 4. Okay, so that's 5 over 2, x to the 4th. Okay, so again, bypass the power rule if the numerator or denominator is a constant. Okay, so let's go ahead and see our main focus for this video, which is the quotient rule, and start at question number 11. Okay, so we ended the part 1 on number 10. So now we have this question number 11. Let's say you have 3 over 5x plus 2. Okay, so what if you have a binomial 5x plus 2 in the denominator? So this is no longer a reciprocal because we have two terms at the bottom, okay? But we can still bypass the quotient rule. So let me show you a different way to do it without the use of quotient rule. And then I'm going to show you the use of quotient rule, okay? So for this one, we can still bring this up, okay? But you have to bring this entire binomial as a whole, okay? So this 5x plus 2 is raised to the first power. So when you bring this up, it becomes 5x plus 2 to the negative 1. Okay, so now we have to use a chain rule. So this is now a chain rule question. So the derivative will be negative 1 times 3, okay, multiplied by 5x plus 2 raised to the negative 1 minus 1, which is negative 2, and then multiply this by the derivative of this 5x plus 2, which is 5, okay? And then go ahead and simplify. So this is negative 3 times 5. It's negative 15 times the 5x plus 2 to the negative 2. Okay? Now, this is understood to be over 1. So, again, you can leave your answer as it is, or you can move this 5x plus 2 to the negative 2 down. So, that's negative 15 over 5x plus 2 squared. Okay? So, over here, I use chain rule if I want to move this 5x plus 2 on top. Now, if I don't do that, I just keep the fraction the way it is. Okay, so what I do is is use quotient rule. Okay, so quotient rule, this is your u and that's the v. So quotient rule says if we have u over v, the derivative is u prime v minus u v prime over v squared, right? So let's go ahead and use that quotient rule formula. So y prime is u prime, which is, okay, so let's have a summary of our information here. My u is 3. Now u prime is going to be 0. Now v is 5x plus 2. V prime is 5. Okay? So following this formula, u prime is 0 multiplied by v, which is 5x plus 2, minus u, which is 3, times v prime, which is 5. Okay? All over that denominator 5x plus 2 squared. So y prime is negative 15 over 5x plus 2 squared. Okay, so we got this same answer right here. Now, what about if we have question number 12, which is 3x over 5x plus 2. Okay, again, our numerator is u, denominator is v. So if u is 3x, u prime is 3, and then if our v is 5x plus 2, our v prime is 5. Okay, so quotient rule says, okay, that again, y prime is going to be u prime v minus u v prime over v squared. So y prime is u prime, which is 3, multiplied by v, which is 5x plus 2, minus u, 3x, multiplied by v prime is 5, all over v squared, which is the denominator 5x plus 2, then square it. So our y prime will be 15x plus 6 minus 15x, okay, over 5x plus 2 squared. And cancel those 15 and minus 15x. So what we got is 6 over 5x plus 2 squared. Alright, so that's purely quotient rule. Now let me show you another one. Let's say, so you have 3x plus 4 over 5x plus 2. So our numerator, once again, is your u, and the denominator is your v, okay? So it's better to have your set of u prime, v prime already available. So on the side, you can go ahead and organize those u, which is 3x plus 4, and then u prime is 3, derivative of u, okay? And v is 5x plus 2, v prime will be 5, right? Derivative of 2 is 0. Okay, so our y prime is u prime v minus u times v prime over v squared. The y prime is u prime, which is 3 times 5x plus 2 minus u, that's 3x plus 4, times v prime, which is 5, all over v squared, so all over 5x plus 2 squared. Then go ahead and simplify. That's 15x plus 6, okay? And then 5 times 3x is 15, but negative, so that's negative 15x And then 5 times 4 is 20 times negative, so that's negative 20 all over 5x plus 2 squared. So 15x minus 15x is 0. 6 minus 20 is negative 14 over 5x plus 2 squared. So this is our derivative. Okay. Now, for number 14, okay, going back to that number 13, okay, for number 13, we use the quotient rule, okay? So 3x plus 4 over 5x plus 2, okay? So you saw the quotient rule um, solution, okay, for this one. But there's a trick or shortcut that we can use for this specific format, okay? So when you have this variable x that are exactly the same on top and at the bottom, followed by constant, so this is like plus 4 and plus 2, so this is your constant, okay? And we have these variables or letters that are exactly the same. So in general, if you have something that looks like, okay, so let's say you have f of x, say a times f of x plus b over c f of x plus d. So this is the function that I'm talking about right here. So this x here is like our f of x, okay? So when the function part are exactly the same, followed by constant, so this is the constant part right here. Now, the way we can get the derivative without the use of quotient rule is this, okay? You simply get the derivative of the function f of x, which is now f prime of x, and then multiply this by AD minus BC, okay? So I'm sure you have seen this before. It's actually a determinant formula. It's a determinant formula, and we're going to be using this as part of our trick, okay? Over that same denominator, so our denominator is c times f of x plus d, okay? So you just pick up the denominator and square it, just like in the quotient rule. All right, so let's see how this works right here. It says get the derivative of f of x. So our f of x here is the variable x, okay? So this is like your f of x. So our y prime is simply the derivative of x, which is 1. So that's your f prime, okay? So that's 1. And then multiply this by AD minus BC. So it says A times D minus B times C. What is your A here? So A is 3, your B is 4, your C is 5, your D is 2. So AD is 3 times 2, right? AD. So you see that diagonal AD, 3 times 2, minus the other diagonal product, 4 and 5, minus B times C, minus 4 times 5. Now, over that same denominator square, just like in the quotient rule. So 5x plus 2 squared. And you're done. You just have to simplify it. So this is 6 minus 20, which is negative 14 over 5x plus 2, okay, squared. So we didn't use the quotient rule. We just use this trick or shortcut. Okay, so let's try another one. Let's say you have, say, 7x minus 5 over 3x plus 2. Okay, let's check. So this is our function right here. So you can see that the function x is the same function you see at the bottom. So we have the same letters, top and bottom, followed by constant negative 5 and 2. Okay? So this is our constant part. That means we can use the shortcut. So our y prime, without the use of quotient rule, is very simple. What is the derivative of this variable x? 1, right? Now multiply that by what? By the determinant AD minus BC, okay? Over that same denominator, 3x plus 2 squared. Okay, so again, this is AD minus BC. Now, this is your A, that's your B, this is your C, this is D, A, B, C, D. So AD, that's your diagonal, 7 and 2, okay? 7 times 2. Minus the other diagonal, BC. BC, that's negative 5 times 3. So be careful, this is negative 5 times 3. Okay, that's it. So our y prime is 1 times, this is 14, and negative negative is a positive 15 over 3x plus 2 squared, which is 29 over 3x plus 2 squared. Now you can verify or double check that our answer here is correct using the quotient rule, okay? So let's take another example using the shortcut. Shortcut for the quotient rule, okay? Let's say you have 4x, let's say 4x squared plus 3 over 2x squared minus 5, okay? So look at the letters. Our letters are x squared, okay? And they are exactly the same, followed by constant. That makes this a perfect form for the quotient rule trick, okay? So what is the y prime here? Get the derivative of the x squared, okay, which is 2x, and then multiply it by the determinant. You call it determinant. It's a simple formula, AD minus BC, okay? So AD minus BC over that same denominator, 2x squared minus 5 squared, just like in the quotient rule, okay? So y prime is 2x. Again, what is AD? A is 4, AB, CD. So AD is 4 times negative 5. So that's 4 times negative 5. And then minus BC. What is your B? B is 3. And C is 2. Okay, so over 2x squared minus 5 squared. So our y prime is 2x multiplied by, this is negative 20 right here, and then minus 6, okay, over 2x squared minus 5 squared. So your y prime is, now this is negative 26 times 2, that's negative 52x over 2x squared minus 5 squared. Right, so that is, again, the quotient rule shortcut. Now, let's see another one. Let's say we have say 2x cubed. Okay, let's say 2x cubed plus 4 over x cubed minus 3. Okay, so look at the variables. The variables are exactly the same. Okay, and look at the numerical coefficients of this x cubed. We have 2 on top. Now, this x cubed below right here means 1. Okay, so our derivative using the quotient rule shortcut is first get the derivative of this letter x cubed, which is now 3x squared, and then multiply that by AD minus BC over that same denominator, x cubed minus 3 squared. So what is AD? This is A, okay, B, C, D. So AD is 2 times negative 3 minus B, which is positive 4, times C, which is 1. Okay? So our y prime is 3x squared times, now negative 6, negative 4 is negative 10 over x cubed minus 3 squared. Simplified to negative 30 x squared over x cubed minus 3 squared. Very easy. Okay? Now let's do another one. Say y equals, let's say 2x to the fourth minus 5 over 3x to the fourth plus 4. So look at the variable x again. Are they the same? Yes, they're both x to the fourth. Now, do they follow by a constant? Yes. So the constants are negative 5 and 4. Again, this is a perfect form for our quotient rule shortcut. So the shortcut is first you get the derivative of this variable x to the fourth, which is 4x cubed, and then multiplied by AD minus BC, AD minus BC, okay, over that same denominator 3x to the fourth plus 4 squared. So AD, okay, minus BC. So our A is 2, D is 4, minus B, our B is negative 5 times C, which is 3. Okay, so that's it. Y prime is 4x cubed times, now this is 8 plus 15, so that's 23 over 3x to the fourth plus 4 squared. Now 23 times 4 is 92, okay? So that's 92 x cubed over 3x to the fourth plus 4 squared. Okay, now challenge for number 18. Can we use the shortcut here, okay? Shortcut for quotient rule. Let's say you have 6x squared plus 6x plus 5 over x squared plus x minus 2. Okay, if you look at the variables, we have x squared and x. But the numerator, you have 6x squared plus 6x. Denominator, you have x squared plus x. So obviously, they're not exactly the same. But if you try to factor out the 6 on the top, okay? If you factor out the 6, what do you have? You got this x squared plus x plus 5, okay? Over x squared plus x. If I enclose this, just to make it obvious that the literal parts are exactly the same now, followed by constant. So again, you can use the quotient rule shortcut here. So our y prime will be, first get the derivative of these variables, x squared plus x, that's 2x plus 1, then multiplied by AD minus BC, so we know it's a 1. So A, so this is your A, B, C, D, okay, so this is the D. So A 6 times D, which is negative 2, minus B 5 times C, which is 1, over the denominator x squared plus x minus 2 squared. Right, so that's 2x plus 1 multiplied by, this is negative 12 minus 5 is negative 17, okay, over x squared plus x minus 2 squared. Okay, so our final answer is negative 17, 2x plus 1 over that x squared plus x minus 2 squared. Okay, very easy using this quotient rule shortcut. Okay, let's do a couple more. Number, let's say number 18. Okay, we have this uh, 9 over e to the x. Okay, so this is a quotient or fraction. So if we take this as our u and this is our v, so our u is 9, its u prime is 0, okay? And our v is e to the x. Now the derivative of e to the x is e to the x. Okay, so if we use the quotient rule, so y is equal to u prime v minus u v prime over v squared. So this is your y prime or derivative of y. Okay, so our y prime is u prime, which is 0, times v, which is e to the x, minus u, 9, times v prime, which is e to the x, okay, over e to the x squared. Now this is cancelled. Now we have negative 9 e to the x over e to the x times this e to the x squared means e to the x times e to the x. And I can cancel this. So what we have right now is negative 9 over e to the x. Okay, so that's quotient rule. Is there a shortcut for this one? Now, what happened if I move this e to the x on top? Okay, and I do that. So when you move this e to the x, what's going to happen to your x? Okay, that becomes e to the negative x. Okay, so let's see. It's no longer a quotient rule, but a power rule question. So what is y prime? It's 9 e to the negative x. Okay, so we're just going to be using a chain rule for this, right? So 9 e to the negative x, and then multiply this by the derivative of that exponent, negative x, which is negative 1. So our y prime is negative 9 e to the negative x. Now you can bring this down. That's negative 9 over e to the x. Okay? Let's do number 19. Say, what if you have 3 over 2e to the negative 4x? Okay, so if it's, again, over e to the negative 4x, you saw number 18 that we can bring this up, okay? And you don't have to use the quotient rule. So if you do the same here, you can bring this up. And now we have 3 e to the 4x over 2. So this is no longer a quotient rule question, but a chain rule. Okay, so we can go ahead and get the derivative right away. So this is 3 over 2 times e to the 4x, then multiplied by the derivative of 4x, which is 4. Okay, so that gave us now, so this 4 and 2 is reduced to 2 and 1. So 2 times 3 is 6. All right, 2 times 3 is 6, and then e to the 4x. Right, so one last question. let's say we have to get the difference. Okay, so let's say number 20, we have y equals 4x plus 3 over x. So obviously this is a quotient rule question. Let's say our u is 4x plus 3 and our v is x. Okay, so organizing our u prime, u is 4x plus 3. Now u prime is uh, 4. Okay, and then v is x, our v prime is 1. All right, so quotient rule says we take the derivative of u times v minus u v prime over v squared. Okay, so our y prime is u prime, which is 4, multiplied by v, which is x, minus u, which is 4x plus 3, times v prime, which is 1. Okay, all over v squared or x squared. Now this gave us our y prime, which is 4x minus 4x minus 3. Okay, when I distribute the negative on top over x squared, or simply negative 3 over x squared. Now, there's a shortcut for number 20. Okay, so if you split the 4x and 3, rewrite that 4x plus 3 over x is also the same as 4x over x plus 3 over x. Now, 4x over x is simplified to just 4. So it's just 4 plus, and if I bring this x on top, that's 3 times x to the negative 1. So that is no longer a quotient rule question. That's a power rule. So our y prime will be 4 is 0, and then negative 1 times 3 is negative 3, x to the negative 1 minus 1, which is negative 2. So this gives us negative 3 over x squared as our final derivative. Okay, so that's all, my friends, for this quotient rule tutorial, part 2, and see you on part 3. Have a great day.